Good morning, everyone. Thank you for joining today's EAC webinar. This is Cassie Stumo. I am the marketing specialist at EAC. We'll begin today's session with an introduction of EAC, and then our technical account manager, Bill Schlund, will take a look at how you can simulate human factors and ergonomics in your CAD designs with Creo. If you're already using Creo and have not used this tool yet, Bill will walk us through how you can use it. And for those of you who are exploring CAD options, then you can decide if Creo is right for you. Stick around after the webinar and we'll talk about a deal we have on Creo packages, and there will also be a short survey you can take to let us know where you're at in your design processes and if we can do anything to help. So everyone will get a recording after the session pending any technical difficulties. Please feel free to drop questions in the chat and we'll answer them after the presentation. I'll pass things over to Jenny to give us an EAC introduction.
Awesome. Thanks so much, Cassie, for that introduction. Bill, if you want to go into the next, there you go. So I just want to start off by giving a quick introduction to EAC. And first and foremost, our mission here is that we help companies transform the way they design, manufacture, connect to, and service their products. So going on to the next slide, so we're not only really a value-added reseller for PTC, but we're really the #1 solution partner for PTC in the country. It's something that we at EAC are really proud of. We offer customers everything they need from product development, such as service lifecycle management software, which helps you create and manage service documentation, product data management software like Windchill, ThingWorks Navigate to help smartly connect your products and/or machines and connect real-time data. And then our customizable EAC productivity apps, which helps you to manage internal product data and gives you visibility to key stakeholders that are really outside of engineering, access to data such as BOM reports, ERPs, accounting systems, and many other systems. So with some of the things that we do is we also implement the Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. So we can assist with things like design and engineering projects like FEA or simulation, reverse engineering. Maybe you guys have a bottleneck and you need to get a project out the door and you can't do it in-house. We can help you with that. We can also help with proof of concepts. On top of that, we also offer webinars and PTC certified training courses for continuous learning. And lastly, we also offer a commercial reseller, or we are a commercial reseller for Formlabs, offering the Form 2, which is an SLA desktop 3D printer that delivers high resolution parts and prototypes for as low as $3,500. So please keep us in mind. We have a really large variety of tools to help your organization save time and money throughout the product development process. So just wanted to give you guys a little intro on what we do.
Good morning, everybody. I am the aforementioned Bill Schlund. I'll be going through the extension today for human factors. There's also another component to that called the analysis extension, but that will look at types of work that you're doing and kind of the percentage of people that could accomplish those tasks. So it's interesting couple of things. They're actually both included in the core packaging currently offered by EAC and PTC. So the first thing I want to talk about in the extension is a variety of different mannequin or people, I guess I should say, or that we could use, a library, a variety of different types of nationalities and percentiles of people we can use to place in our environment. Also, there are libraries of postures. So how do we place these? Are they sitting? Are they standing? Are they reaching? Things like that. Speaking of reaching, there's also a capability of displaying reach envelopes and vision cones. So you can see what the mannequin sees and can see how far he can reach in, basically doing a particular task. And then under the analysis portion, we can take a look at pushing and pulling, lifting and carrying, and it validates your designs against different types of guidelines. So we have RULA, which is the Rapid Upper Limb Assessment Analysis. We have SNOOK, which we have some information from Liberty Mutual, and then NIOSH is the National Institute of Occupational Safety and Health. So basically a variety of different tables that were developed by these different groups to help in analyzing and basically compare the capabilities of people being able to do certain types of tasks. So we'll look at all of that in our presentation today. So let's start with that. I'm going to start off with Creo Assembly that we see here, a variety of different types of components. We can kind of refer to this as a work cell, and we're going to put a couple of mannequins in here, and excuse my zooming around. We'll kind of take a look at the different capabilities and functionalities in the package. So to start off with, I'm just going to pick the Manikin tab right here at the top. There is a mannequin light that comes with Creo, and that was basically, you can just put a certain mannequin in there. You can't save them with your assembly or anything like that. There's just certain capabilities that that person has, but this would get people kind of an idea of how the package works. But we're going to start off, just as with most things in the Creo world, we're going to start off over on the left side of our ribbon and then kind of work our way to the right. So the first thing is we want to insert a mannequin. And as I mentioned before, there are a variety of different types of males, females from different nationalities here. What I'm going to do is I'm actually going to grab a kid. So we have a 10-year-old or a 5-year-old child. And I'm going to say, well, we'll grab the 10-year-old. So it's kind of bring your child to work day here. And I'm going to select him here. And then once he's placed, I just pick a place on the floor. It's placed him. And then we can also control where he is facing. So I could say I want him to face this, kind of face the chair. And then I can hit the little reverse button here and flip him around. Now I want him to sit in the chair. I don't want him to get in trouble. So I'm just going to push sitting here. And he's kind of sitting in the air right now. And I'll just go over here and then pick where I want him to be on the chair. And that places him on the chair. So now we have our kid that we brought to work sitting in the chair. One of the things I mentioned earlier, not only do we have libraries of different types of mannequins, but also of different postures. So we have apply a posture here. And it's sort of like, you just don't want him here sitting, but maybe he's has some other type of posture he's taken. They're kind of broken into macro and micro postures. So in our particular case, we can browse through here and we could say we want to have his legs crossed, and we'll say right leg, or let me see. Yeah, we'll say this. So we apply that and we can see that now his legs are crossed. And another thing we could do is, maybe he's still squirming around and you got to kind of tell him to sit down, quit pushing all the buttons. What would happen then typically is we'd see him kind of come in and say, I'm going to just sit here looking at these different postures. Just kind of cross his hands. So there, now he's nice and safe, not touching anything. Now that we have him in place, we can still manipulate certainly the mannequin. The postures get him in a general position, but then there's this manipulate mannequin capability, which allows us to go in. In this case, I'm going to do a 2D body drag. So basically I can pick on his foot at this point and just kind of move it around, kind of place it back again. But again, once the mannequin is placed, we can move the different appendages around to get him exactly the way that we want. So now that he's in place, we're going to go and put in another mannequin here, working on this particular machine. So again, just going to go in and say, let's insert. In this case, I'm going to go down, we'll say from the USA, 95th percentile. So we'll put a big guy in here, big male. And we'll place him basically right here. So again, he's going to be working on this machine, same type of thing. We're going to say, let's have you facing the machine here. And we can kind of see him placed. One of the things that now that we have him here, I'm just going to say, this is good enough. He's going to be working on this machine, right? And this is a 95th percentile, so this is a big guy. One of the things I could check is, and he has to work on this machine, is sort of his reach envelopes. So I'm going to select on that, now that we have more than one mannequin, we pick on which one do we want to see the reach envelope for. And I'll pick on him. And what we can see is the reach envelope for both the right and the left hand. It's kind of a subtlety. There's a couple different spheres around this guy here. The first one has to do with the right arm and how far that can reach, then the left arm, and then kind of overlapping where you can reach something with both arms. So that's giving us a little bit of feedback. Now, the thing is that he's going to have to put his hand on this component right here. And you can see the reach envelope isn't quite getting to that point. So even visually, we can see right now, even a 95th percentile person standing where he is right now is not going to be able to reach that. So what I'm going to do is we'll kind of turn off our reach envelope here for him. But I'm going to make a modification here, kind of move him a little bit closer. The first thing I'm going to do is go under postures, and I'm going to say, let's kind of have him standing, kind of moving a little bit on one foot. And we can now move him a little bit closer. Now I can use the different, if I select on him, I can move his position. You notice that when we add the mannequins here, they're already placed in different, in our model tree here. I can pick on our guy, and I can just say, edit definition. That's just another way of going at it. But again, I'm just going to kind of move him forward a little bit, and maybe off to the right, just a smidge. We can see that he's placed here. So just, it's a regular assembly. One of the things you'll notice with the assembly, though, is that all his different body parts are locked, right? So we can manipulate them through the mannequin feature, but not really as we would with a subassembly, with doing redefines and things like that. So now that we have him there, we have him a little bit closer. What I can do is I can go over to reach. And I'll say I want him to reach, and we'll say, his hand. We could say over on the hydraulic cylinder here. So now his hand is placed. I could say also maybe line it up with this plane a little bit because his hand is on that for right now. And then come back into manipulate, and just maybe do the body drag again on him, just so we don't have any overlap. Move his hand up like this. So now he's placed, has his hand on the correct representation of our hydraulic cylinder, and he's ready to go. So let's zoom out a little bit. Another thing that we can look at with the Human Factors library is he's going to be working on this machine. So what can he see? So again, we can go over here and we have something called a vision cone. So like we had reach envelopes, we can also do that with the eyes. So I could say, let's see the vision cones for him. Again, we have some different colors of what the vision cone is. First of all, it's peripheral vision. So that's these larger kind of green spheres. There's a real subtlety here. Right here, you can kind of see it on this side and then over on this side. This is where both eyes overlap, right? So both eyes can see in this area. Then we have this kind of a red cone that we see right here, and that red cone represents, basically would refer to as kind of the optimal vision. And then also we have a very small little blue cone, which is showing exactly where he's looking at. And that's really where you would focus if you're going to read something, right? So that's a very, very focused place. And that gives us an idea of where he's looking. So one of the things we can do with this is really nice, is I can come over here and say, let's look at the vision window. So what do we see if we're looking through his eyes? We'll pick on him and we'll pop up our vision. And so this is where he's looking at right now. So we can see, he can keep an eye on his kid that he brought to work today, make sure that he's not getting in any trouble, but he also has to work with the machinery. So in this particular case, I'm going to take our vision cones and turn them off for this guy. But we can come over here and we can use something called look at. And we'll say, this guy, we want him to look at this part of the machine. Right? So you notice that his eyes have changed, or his location of his head. And we can see this updating. So another thing that we could do is if we want to manipulate this a little bit more, I can go under manipulate. And we're going to say this time rotate around an axis. I can pick maybe the axis in his neck here. And then now I can kind of drag this and we can turn his head. And you can change his view. So again, we can get an idea of, and this is really good in maybe heavy equipment or something like that, put the person in the cockpit or in the seat of the heavy equipment and look out his eyes and see what he can see. Can he see the dashboard and all the levers or dials that he needs to read? And then also, can he see other people maybe out in front of the vehicle so that he has a clear field of vision? So actually, this is a very useful capability to go in and basically be able to look through the mannequin's eyes to see what he sees. Also, once I have these things, I have, this child sitting here with his arms crossed. I have the mannequin here with his hand on the hydraulic cylinder and looking at the machine. I can save that posture. So we have this library of postures, right, that I've been using up until now. I can also create my own once I have somebody in a particular setup that I like and I might want to reuse that again. I would just say save the posture, give it a name, and then I would be able to recall that and apply it to any other mannequin going forward. So it's kind of captures all the positional information of the mannequin. Doesn't matter his size or nationality, it'll be applied to any mannequin that you use in a future point. So another thing that I want to touch on as we zoom back here a little bit is we have another place where we can make use of a mannequin. In this case, I'm going to go in and say, let's insert another one. We've got children, we've got men, haven't picked on any women yet. So let's go in and maybe grab 50 percentile Italian. And say, let's place that individual maybe right here. And we'll say maybe our location, maybe up right here. And we'll say, let's face the boxes here. So you can see our individual is placed here. And obviously this person is going to be working and pushing this cart. So one of the things I want to do for a posture for her is to come in and say, let's grab a posture that, let's say pushing. So you can see we have a variety of different postures here for pulling, for pushing. We got Southern Shaolin praying mantis style. So there's a lot of different things, certain varieties of different seated positions. But in this particular case, we're going to say that we're pushing something low, and we're going to apply that to our person here. So placed, but we actually want to put her hands on the handles here. So again, just as I did before, I can just use the reach command and say, let's put this hand on the handle right here. And then let's place this hand on the handle here. And I'm placing them on points, but I could also project those points and just pick on the surface itself. Now that the hands are there, I want to apply a posture to the hands. Again, that comes under the heading of micro, but basically we're controlling the type of grip that this person would use. In this case, we're going to say, let's apply a cylindrical grip to the right hand, to this person here. So we'll see the right hand grab on, and then the exact same thing again. We'll say a cylindrical grip on the left hand. You don't have to pick on the hand, you just have to pick the mannequin and it gets applied to the hand. So now we've got the person pushing our cart. And now we can start to think a little bit more along the lines of the analysis of this. In this particular case, we have an individual pushing a cart. So We can look at different things here. We can find the center of gravity of the individual. That'll just either display it or not display it. But we can use RULA analysis. So RULA, as I mentioned before, was sort of the rapid upper limb assessment. It's really something that would be used for someone who's manipulating a tool or an object in their hand. So it wouldn't really necessarily apply here, but I'm just going to do it just so you can kind of see the interface a little bit. And we're going to say, are they manipulating with the right arm or the left arm? In this case, we're pushing, so we're using both, but we can look at that. Which mannequin are we concerned with? We'll say this one. One of the things it also looks at is how the person is supported, not only the arm, but the torso and the legs for manipulating this particular product. It could be lifting a bowling ball or spinning a pencil. There's a big difference there, but how is the body supported with that? And at this case, and we can check off the different boxes that we wanted to compute or look at. In this case, RULA is going to come back and say, okay, it gives it a score of 3. What does that mean? So if you get a score of 1 or 2, that's good. I mean, it's an acceptable question. If it's 3 or 4, you might want to do a little bit more investigation into it. 5 or 6 means you need to make some modifications, and if you get a value of 7, it means you immediately need to make a modification. So why is it giving me a 3 or a 4? And it's not really looking at the person and how they're walking and that they have their hands balanced on here, but it's looking at the right arm and saying if the person was standing like this and manipulating a tool, that's not a real comfortable position to be in. It's not a real good kind of way of dealing with that. So it's just giving me some feedback on that. And like I said, for this particular example, this probably wouldn't be something that you would run on it. It would be more or less something if someone is holding something in their hand and manipulating it that way. So let's look at something that is a little bit more applicable. And in this case, she's not really lifting anything, but she's pushing, right? So I'm going to let's do some a snook analysis on this. And again, this is from Liberty Mutual. Again, they've done all kinds of ergonomic studies on people and what the average person is capable of doing. So that's kind of what we're going to look at it here. So who are we going to do the study on? It'll be this person right here. I'm just kind of filling in as we go along. The person in this case is pushing, and the distance 7 feet. Let's say you got to push at 50 feet, and once every 30 seconds. That's kind of a lot. We'll say once every 5 minutes. Now the initial load when the cart is still it takes a little bit more force to get it going. Once it's rolling, it's a little bit less. So we'll say to get it going, about 35 pounds of force. Once it's rolling, maybe 25 pounds. At this point, I can say, let's compute. So it's going to go off and come back and look at the design goals and how often it goes here. And then this is really kind of the important part, these last couple of areas right here. For men, it's 90% of men can do this, right? Push this 35-pound cart initially for 50 feet every 5 minutes. And then for women, it's about 70%. So we're not asking too much. The average person should be able to do this. But if we bump this up to maybe 60 pounds and we'll say maybe 45 once it's rolling. So it's a heavier cart, and we'll say you got to do it every minute. So not a fun job. But if we go over here, say compute again, comes back. Now only 45 or 43% of the men can do that, and less than 10% of the women. So a very, very heavy cart pushing at long distances every minute. So it gives you a little good idea of the type of tasks that you're asking and what the human capabilities are for doing such a task. Now there's another thing that I haven't really touched on. We saw under the postures that there's a variety of different postures for sitting. You can see like sitting in a vehicle or something like that. There's also something referred to as the comfort analysis. So if a person is in a position for a long time, so like hopefully this kid will be sitting in the chair for a long time and not running around, we could look at the comfort of that in the position that they're in. So here, sitting down in a chair, it's going to be fine. But what if they're on a motorcycle, right? And you got your foot on the pegs and you're going to go for a 4 or 5 hour ride. How comfortable would you be in that particular position? Because your hands are pretty much on the handlebars the whole time, your feet are on the pegs the whole time. And we actually have done this type of things with motorcycle companies. And what we can find out is that maybe we need to adjust the pegs a little bit to allow for more comfort over long road trips, or have a second set of pegs, right, to put your feet on. So maybe one for, you know, short drives and then other for the long hauls. So lots of different information that can be derived once you place your mannequins in the assembly. Again, we have real kind of a virtual representation here of the work zone that we're working in, so we can get real-time accurate feedback, just like we can with the whole idea of working with Creo and being able to kind of create a virtual product and be able to test it out before you actually commit time and resources to enacting that. So that kind of brings us to the end of the presentation that I was going to go through. I'm going to turn it back to Jenny and Cassie, and we'll open it up for any questions and some closing comments.
Thank you so much to everybody that's attended today. We just want to finish up, let you guys know that there are a couple deals going on with PTC. It goes on until the end of next week. So there's the buy two, get one free seat of Creo packages. So your Creo Design packages, your Creo Design Essentials, Advanced, Advanced Plus, Premium, and Premium Plus. And then also, if you are looking to expand on MathCAD licenses or even add MathCAD into your environment, that is also buy two, get one free as well. So please reach out to me if you guys have any questions on that. Other than that, thanks so much for attending, and we really look forward to continuing to see you guys on these future webinars.